Okay, guys, now in this session, in this video, we will talk about multiplication of matrices. That is a little bit different, maybe comparing to other operations like addition and subtraction and multiplication of a matrix by a real number. It's a little bit different and quite challenging if you are doing it for the first time. And of course, after practicing a few questions, it's also easy stuff. But usually students, if you did not study this matrix before, if you never studied multiplication matrices, it may be a bit weird for you for the first time. But after practicing a few questions, you will see that is also not so complicated stuff. Okay, so multiplication of matrices. The matrix multiplication is possible only when the number of columns in the left matrix is equal to the number of rows in the right matrix. Okay, so that's a definition. When you are giving a definition, and for all of a sudden, actually, mathematicians, they don't actually introduce definition. Actually, definitions are born through a lot of experiences. When they experience a lot of things, some operations, they deserve a special name or special operation or special, how to say, you will see that the same thing you will see very frequently in the process of solving problems. Then actually they define something special, and after that it is used in solving problems. One of such things is matrix multiplication. To define this, in the first place, we are saying that if we want to multiply two matrices, let's say this one is matrix A, I want to multiply this by matrix B. First is saying that what is the dimension of this matrix? We know how to determine the dimension of matrix, right? I mean the order of matrix. How many rows and how many columns does it have? Let's say it has m rows and n columns, right? And the second matrix, let's say it has p rows and q columns. All right. And we are saying that we can multiply these two matrices together. And how we multiply is another question. We will answer that question a bit later. First, we have, when you look at two matrices, now you are asked to multiply. So you have to be able to decide, is it possible, I mean, not to determine, is it possible to multiply these two matrices or not? So here, to do this, first you need to check these two things. Are they equal or not? What is this? It is the number of columns of the first matrix. And how about this one? It is the number of rows of the second matrix. And here we say that if this n is equal to p, then it is possible. Then we can multiply these two matrices. And the resulting matrix, if you multiply these two matrices together, and also we will have another matrix, and the dimension of this matrix will be m by q. That is m by q. That means that the resulting matrix, it has m rows and q columns. Okay, m rows and q columns. Okay. So to do this one, let me just show you a few examples, for very simple examples. All right. Just a minute. I forgot to. All right. Okay. Let's start with this example. Suppose Alan bought three pencils, 2 ballpoint pens, and 4 exercise books. Okay. The cost of each item is 15 cents and 25 cents and 40 cents, respectively. Using a matrix multiplication, find the cost of the purchase. Okay. First, without using the matrix, if you want to find the total purchase, how can you find this? Here we have 3 pencils, right? And each one is 15 cents plus, and here we bought 2 ballpoint pens, that is 2. Each ballpoint pen is 25 cents plus 4 exercise books and 40 cents. Each one is 40 cents. All are in cents, right? So now I can just do this multiplication. 3 times 15 is 45, and 2 times 50 is 50. It is 95, 160, 160 plus 95. It is 250. What is it? 160. Wait, 45, 50, 110, 150, 95. Here we have 160, right? It is 255 cents. So you pay this much. Okay. Now, how do you actually also do this using matrix multiplication? As you see here, the first one I multiply by the first one, second one by the second one, third one by the third one. So if I just write this in this form, let's say this items, okay, this items, what is it? It's product or something, let's say Q, okay, and this one is price. Let's say the multiplication of 2 matrix gives us this. Let's say here, this items quantity, the first one we bought 3, second one it is 2, third one it is 4, okay. And let me just write this matrix in this way. The first one's price is, individual price is 15 cents. And here we have the second one is 25 cents. And third one is 40 cents. Okay. And also we can write in this way. Now we will define how to multiply matrix. When I just write in this form, this is a matrix, this is a matrix. How do I multiply? What we have here? Here we have row matrix, right? Row matrix. Here we have column matrix. And what is the dimension of this matrix? It is 1 by 3. What is the dimension of this matrix? It is 3 by 1. These two things, are they equal? Yes. The resulting matrix will be here 1 by 1. So here we will have only 1 by 1 matrix, only one entry here. Okay. So to multiply a row matrix by column matrix, the first requirement is the number of columns of the first matrix must be equal to the number of rows of the second matrix. Just write the dimension of the first one, the second one, and draw a rectangle. These two numbers, are they equal or not? If yes, continue. If not, just stop and write. It's not possible. Okay? So if they are equal, the resultant matrix order will be 1 by 1. To do this one, how can I do that? Multiply the first entry by the first entry, plus second entry by the second entry, plus third entry by the third entry. So that gives us this result, 255. It is the same thing with this. Multiplying in this way, multiplying 2 methods together, it's exactly the same. This is how we multiply. This is how we multiply a row matrix by column matrix. Okay. Some other examples. Another example. Let's say I need to multiply this 3, 2, 5 by, let's say, 3, 7. First, is it possible to multiply these two matrices? Check this out. Here we have 1 by 2, and this one is 2 by 1. And these two numbers are same, so that is possible, right? And the resulting matrix order will be 1 by 1. So that is equal to, here we have one answer only. How can I do that? To do this one, multiply the first entry by the first entry, plus second entry by the second entry. That is 2 times 3 plus 5 times 7, which is equal to 6 plus 35, that's equal to 41. So here, the resulting matrix is 41. Okay, another example. Let's say here we have 1, 2, 3. And here we have 4, 5, 6. First, we have to determine actually, is it possible to multiply these matrices together or not? So this matrix is 1 by 3 matrix. This one is 3 by 1. So these numbers are equal, right? And the resulting matrix will be of this order. So here we have this, right? 1 times 4, it is 4, plus 2 times 5, it is 10, plus 3 times 6, it is 18, which is equal to 28, 32. So the answer here is 32. Okay. All right. Now I think it is clear, you know, how to multiply a row matrix by a column matrix. All right. Now instead of this, if I just change the previous question into two things. Let's say here in the previous example, Alan bought these things, right? And again, assume that two people went to the shop. Alan bought 3 pencils, 2 ballpoint pens, and 4 exercise books. And also here, let's say here we have Benny. Benny, he got 5 pencils and the 4 ballpoint pens and 10 exercise books. All right. Now, if I make a table here, what we have here? Here we have these things. Okay. Here we have Alan, here we have Benny, and they bought 3 different items. All right. The first one is pencil. Second one is ballpoint pencil. Third one is exercise book. Right. Alan bought how many pencils? 3. Right. And the 2 exercise books, 4. Right. How about Benny? She bought 5 pencils and 4 ballpoint pens and 10 exercise books. Let's say these two, they are siblings. Okay, they went to the shop, and the question is, together, how much did they pay? If we answer this question again, look, with this matrix multiplication, I can do like this. First, let me just write it as a matrix. Here we have 3, 2, 4. Here we have 5, 4, 10. And the prices. Price of this item, how much is it? It is 15. Here we have 15. Price of the second item, 25 cents, right? And price of the third item, it is 40 cents. Now, what is the dimension of this matrix? It is 2 by 3. And what is the dimension of this matrix? It is 3 by 1. So these numbers, are they equal? Yes. So the resultant matrix order will be 2 by 1. What does 2 by 1 mean? It means it has 2 rows and 1 columns. Here we have 2 rows, the first one, and this is the second row, right? 2 rows, 1 column. Now to get this thing, let me just write here with numbers B1, 1, B sub 2, 1. And this is how we use, to denote the entries of the matrix. What does 1 by 1, B sub 1, 1 mean? It means this entry is at the intersection of the first row and the first column. And this thing means this first represents row. It is at the intersection of the second row and first column. 2, 1 means second row and first column. Okay. Now let me just write here to get this B sub 1, 1. B1, 1 means starting from this one. Multiply the first row by the first column. All right, first matrix, first row, second matrix, first column. That is equal to 3, 2, 4, and multiplied by 15, 25, 40, which is equal to, we have already done here, that's equal to 255. So this B sub 1, 1 is equal to 255, right? And second thing, how about B sub 2, 1, right? So B sub 2, 1, again, this is really important in matrices, this subscript notation. Here, that means that multiply this 2 and 1, right? The first matrix, second row is, what is the second row of the first matrix? 5, 4, 10. 5, 4, 10. multiply the second row by the first column of the second matrix. Set is 15, 25, and here we have 40. And if you multiply this, let me just do this using term. It is 75 plus 4 times 25, 100, plus 10 times 40, 400. That's equal to 575. This thing is equal to 575. So now I can write the result here. That is 255. And second one is 575. Okay. Now 255, 575. That is these two guys paid. Let's continue here. So that thing is 255, 575. Let's say this one, how much Alan paid. This one, how much Benny paid, right? And I'll continue. Another question. How about if we ask how much all actually in total these siblings paid together? I mean, what was the total cost of these two siblings? To find the total cost, I need to add these two things, okay? So again, I need to create another matrix because I want to do everything with matrices. How about if I multiply this thing, 1, 1, and here we have 255 and 575. Okay, so what is this matrix dimension? It is 1 by 2. This one is 2 by 1. So these two numbers are the same. So the resulting matrix will be 1 by 1, only one entry. To multiply this one, we know how to multiply a row matrix by column matrix. The first entry by the first entry, 1 times 255 plus 1 times 575, which is equal to 255, 575, that's equal to 70, right? That's equal to 830, is it? So here we have 830, $8.30. Together, they paid $8.30 to the shopkeeper or the seller for all the stationery they bought from the shop. Okay, that is all about multiplication of matrices. Now I'll show you a few more examples. Another example, find the product of these two matrices. The first thing you have to do is first write their orders. The first matrix order is 2 by 2. Second one is 2 by 3. Okay, then it is possible because these two numbers are same, equal. Now the resulting matrix will be 2 by 3. If I say that this matrix is A, this matrix is B, so if I multiply them together, A times B, now I know that the resulting matrix will be 2 by 3. So I will get something like this. 1, 2, 3, 1, 2, 3, right? So if I just write the entries here, this one is C1, 1, because it's at the intersection of the first row and the first column. This one is C sub 1, 2, first row, second column, C1 sub 3, first row, third column. How about here? We have C sub 2, 1, second row, first column, and here we have C sub 2, 2, second row, second column, and here we have C2 sub 3. Okay. Now to get this entry, what does 1, 1 mean? It means multiply the first row by the first column. This C sub 1, 2 means 1, 2. It is first row by the second column, right? And C1, 3 means first row by the third column. So if you multiply the first column by each column, we will get these entries. In a similar way, to get the second row, I need to multiply the second row by each column. Okay, that is how we multiply matrices. And there's actually, of course, there's a exact rule, but I'm not going to give you with some of these notations. You may get confused with this them in linear algebra, but just basic things here, how to multiply 2 by 2 matrices or 2 by 3 matrices, something like this. If you know how to multiply this that much, that's enough for you for this course. So let's do this here. Now let me just write here A times B, that's equal to the first one is 3, 2, 1, 7, and second matrix is 2, 1, 0, 4, 6, 3, and is equal to, so I'm going to write these entries here. 1, 2, 3 here, 1, 2, 3. First, let me evaluate C sub 1, 1. C sub 1, 1. So that is the first row. Here we have first row and first column. First column is 2, 4, right? First column. First row, first column. 3 times 2, 6. 2 times 4, 8. Well, actually, anyway, that's equal to, what is it? 14. So here we have 14. So this guy is 14. Second one, C sub 1, 2. C sub 1, 2. All right. To do this one, first row by the second column. First row is again 3, 2. Second column is 1, 6. It is 1, 6. Now you know how to do that. 3 times 1, 3. 2 times 6, 12. That's equal to 15. So this guy is 15. Third one, C sub 1, 3. That's equal to first row. It is 3, 2. And third column, because here we have 3, 0, 3, 0, 3, which is equal to 0 times 3. 0, 2 times 3, it is 6. So here we have 6. Okay. In a similar way, I can do the same thing for the second row, C sub 2, 1. Here we have 2. That means that the second row by the first column. Second row is 1, 7. And the first column is, what is it? 2, 4. 2, 4. Now let me just write the answer here. 1 times 2, 2. 7 times 4, 28. Their sum is 30. So here, this guy is 30. Okay, and C sub 2, 2, C sub 2, 2. That means that second row, it is 1, 7. And the second column is 1, 6, 1, 6. 1 times 1, 1. 7 times 6, 42. So that is 43. So this guy is 43. And the last one is C sub 2, 3. That is second row, 1, 7. And here we have third column, 0, 3, which is equal to 1 times 0, 0, 7 times 3, 21, which is equal to 21. Okay. Now, after practicing a few questions, again, you don't have to write this one by one. You should do this mentally. Okay, now I'll show you in the next example. So you need to know, we are going through these steps actually to multiply these two matrices together. Okay, so you need to know how to multiply first row matrix by column matrix. And after that, if you know that, we can just expand this to the matrices of any dimension where multiplication is possible. Okay, example 8. Example 8. Here we are given that matrix A 1, 3, 4, 7, B it is 1, 0, 0, 1, and C it is 2 by 3. Matrix 1, 2, 3, 4, 5, 6. Find the products AB, BA, BC, and CB where possible. Okay, so let's start with the first one. Let's say this A times B. And what is the dimension of A? It is 2 by 2. Dimension of B, 2 by 2. So that means that it is possible, right? Now I know that the resultant matrix will be 2 by 2. So here we will have something like this, 2 by 2. Okay. Now to get this entry, as you know that I need to multiply the first row by the first column, right? Let me just write here, this thing is C sub 1, 1, C 1, 2, C 2, 1, C 2, 2, which is equal to C sub 1, 1 is first row, right? First row by the first column. 1 times 1, 1, 3 times 0, 0. So here we have 1. How about C1, 2? It is the first row. Now I should multiply it by a second column. 1 times 0, 0, 3 times 1, 3. So the sum is 3. Now C sub 2, 1. That is second row by the first column. 4 times 1, 4, 7 times 0, 0. The sum is 4. And C sub 2, 2. So that is second row by the second column, 4 times 0, 0, 7 times 1, that is 7. Okay, that's it. But if you notice here, we get exactly the same matrix, right? 1, 3, 4, 7. Why is it so? Actually, in matrices, this number is called identity matrix. So that is, we call this identity matrix. Here we have 1, 0, 0, 1. All the entries in the main diagonal, they are ones, and all other entries are zeros. In such case, if you multiply any 2 by 2 matrix by I, that's equal to itself. In real number system, it's like 1, because we know that in real number system, if you multiply any number by 1 is equal to itself. But in matrix, that 1, we denote it by I. For example, another identity matrix were 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. That's also identity matrix. It's a square matrix. It must be a square matrix. All right. So if you multiply by any matrix, if it is possible, if multiplication is defined, so here we have B times I is equal to always B. Okay, next time if you say this, even you don't have to multiply this. Immediately I can write that A times B. Since this is an identity matrix, the result will be A itself. Done. All right. How about B? It is B times A. And also B times A, B times A. And what is B? B is identity matrix. Let me just write here I times A, and that's equal to A itself, which is equal to 1, 3, 4, 7. 1, 3, 4, 7. Because this one is identity matrix. C, BC. BC. Here we have C, let's say B times C. What is B? It is 2 by 2. C, it is 2 by 3, right? And also you see here it is 2 by 2. And this B is identity matrix. You will see that you will get the same thing. And also here we will get, this one is I times C is equal to C. If you can just check it out. Here, 1 times 1, 1, 0 times 4, 0. So here we have 1, the first one. Second one, 1 times 2, 2, 0 times 5, it is 0. So here we have 2. Multiply this by the third one, 1 times 3, 3, and 0 times 4, 6, that's equal to 0. Similar way, if you multiply the second row by each column, you will get the second row. Okay, that's why it's equal to C. And CB, for example, here we have, let's say D. How about C times B? Is it possible or not? What is the dimension of C? It is 2 by 3. What is the dimension of B? It is 2 by 2. If you look at these numbers, right, they are not equal. So that means that it is not possible. Okay, one simple example for multiplication of matrices. Another example, I think I will finish today's class with this example. We have 1, 2, 3, 4, 5, 6 questions. These are all 2 by 2 matrices. That means that all these multiplications are possible. Actually, by doing this, we are going to prove a few theorems here. Because in real number, we know that if you multiply 3 by 5, that's equal to 5 times 3. That means that they have commutative property. That is, A times B is equal to B times A. But here, we will show that in matrices, A times B in general is not equal to B times A. Okay, in general. We don't have such a rule. If you multiply A times B and if you multiply B times A, they are not equal. So we will prove this in this example. A times B. Now I will do this a bit faster. I hope that you understand how we multiply two methods together. It is 1, 2, 3, 4. Second matrix is 3, 2, 1, 4. So the resulting matrix will be 2 by 2 matrix. Okay. First row by the first column. I put here 1 times 3. 3, 2 times 1. 2, the sum is 5. Right? First row by the second column. 1, 2. So I'll put the result here. 1 times 2. 2, 2 times 4. 8, the sum is 10. Now the second row. Second row by each column. Second row, 3 times 3, 9. 4 times 1, 4. 9 plus 4, it is 13. Right? And second row by the second column, 3 times 2, 6. 4 times 4, 16. The sum is 22. Right? Our question B, it says B times A. B times A. What is B? B is 3, 2, 1, 4. 3, 2, 1, 4. And the A is 1, 2, 3, 4. And it's 2 by 2 matrix, 2 by 2 matrix. So here we will have 2 by 2 matrix. 3, 2, 1, 4. Okay, multiply the first row by the first column. I get this entry, right? 3 times 1. 3, 2 times 3. 6, the sum is 9. Here, first row by the second column, 3 times 2. 6, 2 times 4. 8, 8 plus 6, 14. Done. Second row, now we need to multiply second row by each column to write all the entries in the second row, right? 1 times 1. 1, 4 times 3, 12. So here we have 13. First row by the second column, 1 times 2. 2, 4 times 4. 16. So the sum is 18. If you look at these two matrices, what we see here? The first entry, 5. Here we have 9. So we are done. We can say that these two matrices are equal. What we have here, A times B. Here we have B times A. It's just proof for this. A times B is not equal to B times A in general. For very special matrices, they may be equal, but usually they are not equal. We cannot take it as a rule. Okay. How about BC? If you multiply BC here, B times C, that is equal to what is B? 3, 2, 1, 4, 3, 2, 1, 4. And how about C? 1, 0, 2, 3. All right. So this one is 2 by 2, and this is also 2 by 2. Also, the resultant matrix will be 2 by 2. So to write the entries in the first row, I shall multiply the first row by each column, right? 3 times 1, 3, 2 times 2, 4, the sum is 7. 3 times 0, 0, 2 times 3, 6, the sum is 6. 1 times 1, 1, 4 times 2, it is 8, the sum is 9. 1 times 0, 0, 4 times 3, it is 12. Okay. Question D, here we have question D. Associated property. Here we have A times B, and here we have C. What does it mean? First, you multiply this AB together, then multiply the resultant matrix by C. Equals, do we know AB? We have already calculated here. AB equals this. So here we have 5, 10, 13, 22. And do we have C? Do we know C? It's given. It is 1, 0, 2, 3. Right? Which is equal to, so 5 times 1, 5, 10 times 2, it is 20, so here we have 25. So multiply the first row by the second column. We write here 5 times 0, 0, 10 times 3, 30. The sum is 30. Here we have 13 times 1, 13, 22 times 2, 44, 44 plus 13, that is 57. 13 times 0, 0, 22 times 3, it is 66. Okay. E, how about here? A times BC. A times BC. That means that first I should multiply B by C together, then multiply A by the result. We know A, it is 1, 2, 3, 4. Here we have 1, 2, 3, 4. How about BC? We did it here, 7, 6, 7, 6, 9, 12. So that is equal to 1 times 7, 7, 2 times 9, 18. The sum is 25. 1 times 6, 6, 2 times 12, 24. The sum is 30. Right? And 3 times 7, 21. 4 times 9, 36. The sum is 57. 3 times 6, 12. 4 times 12, it is 48. The sum is 66. Now from here, as you see here, first multiply A by B, then C, or multiply B by C and A, they give the same result. So these two things are equal. Okay. And F, A squared. What is A squared? A squared is A times A, which is equal to 1, 2, 3, 4, and 1, 2, 3, 4. That is equal to 1 times 1. It is 1, 2 times 3, 6. Here we have 7. Here we have 1 times 2, 2, 2 times 4, 8. Here we have, what is it? 10. 3 times 1, 3. 4 times 3, 12. This is 15. 3 times 2, 6. And here we have 16, 22. Okay, this is how we square a matrix. Guys, that much is enough. Some other examples I'll make a video and share with you. Okay, I'm going to finish today's class. If you have any questions, you can ask through Telegram group, because now here we have less than 1 minute left. Okay, tomorrow you will have quiz. It will start around 10:10. Today you will receive email, okay, about your quiz time and everything. Maybe in the morning, I don't know. I'll try to finish it today. All right. Thank you very much. Have a good day. Enjoy your lunch. See you tomorrow. Bye-bye.